In this video, we are going to discuss about acceleration. Acceleration, the rate of change of velocity with time. Is called acceleration. Now, the average acceleration A bar or A average over a time interval is defined as the change of velocity divided by the time interval. Therefore, A is equal V2 minus V1 by T2 minus T1, that is equal delta V by delta T. Consider this is equation number 1. My dear students, once again I am repeating the concept. The rate of change of velocity with time is called acceleration. Now, the average acceleration A bar or AV over a time interval is defined as the change of velocity divided by the time interval is called average velocity. Therefore, A bar is equal V2 minus V1 by T2 minus T1, that is called delta V by delta T. Consider equation number 1, where V2 and V1 are the instantaneous velocities. Instantaneous velocities are simply velocities at time T2 on T1. Now it is the average change of velocity per unit time. Therefore, the SI unit of acceleration is meter per second square. Therefore, A average is equal limit or instantaneous average is equal limit delta t tends to 0 delta v by delta t, that is equal dv by dt. Consider this is equation number 2. Once again, my dear students, I am repeating the concept where v2 and v1 are the instantaneous velocities or simply velocities at the time t2 and t1. It is the average change of velocity per unit time. Therefore, the SI means System of International. The SI unit of acceleration is meter per second square. Therefore, A is equal limit delta t tends to 0. Delta v by delta t, that is equal dv by dt. Consider equation number 2. Therefore, the acceleration at an instant is the slope of the tangent to the velocity time curve. At that instant. Once again, the acceleration at an instant is the slope of the tangent to the velocity time curve at that instant. Therefore, now I can draw a diagram to make you understand easily. Now take x-axis, take y-axis. Here it is 2.4, it is 4.8. The velocity I took on y-axis, it is horizontal O. On x-axis, I took time. The time is in seconds. Now what is the time? 2, 4, 6, 8, 10 seconds. Now here Please observe carefully from this diagram. What is acceleration? The acceleration A is equal 4.8 because this is 4.8. This is 4.8. This is 4.8 by 10. That is equal 0.48 meter per second. Therefore, the acceleration A is equal 4.8 by 10. That is equal 0.48 meter per second square. Therefore, the acceleration can also be the acceleration can also be positive, comma, negative, or 0. Here, once again, I am giving the brief about acceleration. The rate of change of velocity is called acceleration. The rate of change of velocity is called acceleration. Here there are three types of the accelerations. Point A, positive acceleration. Point B, negative acceleration. Point C, zero acceleration. Zero acceleration. Okay, now we are going to discuss about graphs about positive acceleration, negative acceleration, zero acceleration. Now, positive acceleration. Suppose point 1. Position time graph. Position time graph for motion of an object with positive acceleration. That is, on x-axis I took time. On y-axis, I took displacement or position. If it is positive acceleration, the graph should be like this. So, this graph indicate positive, acceleration. Now, point 2, position time graph. Position time graph for motion, of an object with negative acceleration. With negative acceleration, that is, take on x-axis, take on y-axis. On x-axis I took time, on y-axis I took position. Now if your graph is like this, this will shows the acceleration is negative. Now, point number 3, position time graph. Position time graph. Position time graph for motion of an object with zero acceleration. Now take x-axis, take y-axis. X is position, time is on x-axis. Now take, if it is a straight line like this, in this case the acceleration is equal to 0, called zero acceleration. Next, note, now take a straight line here. Initially t1 is equal to 0, here t2 is equal to t. Initially velocity v0, finally velocity v. Consider like that. Now take a path in which initially time t1 is equal to 0, t2 is equal to t. V, initial velocity is equal to v0, final velocity is equal to v. Now if the velocity of an object, is v0 at a time t is equal to 0 and v, yet time t T is equal T. Therefore, we have the acceleration is equal V minus V naught by T2 minus T1, that is equal V minus V naught by T minus 0. Therefore, A is equal V minus V naught by T. Consider equation number 1. Or V minus V naught is equal AT. Consider equation number 2. Or V is equal V naught plus AT. Consider equation number 3. My dear students, this note is very important. Please keep mind the gap. Thank you very much for watching this video. Thank you.